first type of continuous distribution that we're going to talk about is the normal distribution. Many different characteristics that we find occurring naturally in nature follow this normal distribution. We've talked about it in class several times before. It has the bell-shaped curve. Some other characteristics of a normal distribution is that we find that the mean is located right in the center. We have 50% of the values above the mean, 50% of the values below the mean. We also know that the empirical rule applies to a normal distribution, which means that approximately 68% of all of the values are going to lie within one standard deviation of the mean, either higher or lower. Approximately 95% will lie within two standard deviations of the mean, and about 99.7%, or just about all values, will lie within three standard deviations of the mean. I want to look at an example, talk about it a little bit, and show how that works in StatCrunch, the software. And this is another thing that we've talked about already. An IQ test is one score, one thing that's known to be normally distributed, and it's known that there is a population mean of 100 and a population standard deviation of 15. And when we know that much about a normal distribution, we can use z-scores. If we were trying to compute this by hand, we could compute a bunch of z-scores and look up the probabilities in a table, but we also have the software that can handle that for us. So within StatCrunch then, we will go to our Stat button right up here, click on that, and it's going to be under Calculators to start off. And you'll remember we see the binomial calculator, the hypergeometric and Poisson calculators that we talked about with discrete distributions last time. But we also have a calculator for the normal distribution here. So we'll just click on that. That brings up our diagram here, and essentially we're just going to put in the information that we have. We have our mean of 100. We have our standard deviation of 15. And then we're going to look for whatever we're interested in. Let's say that we were interested in finding out the probability of having an IQ score of 120 or less. So we're going to put in here P of x, the probability that x is less than or equal to 120. We click compute or hit enter. Either way will work. And it shows it to us in a couple of different ways. It shows us here that our exact probability is right at 91%. So 91% of every person's IQ is going to be at or below 120. And then also it shows us graphically the red shaded area from 120 all the way back to 0 then. And it definitely would appear to be right at 90% or so of that graph. So that's how we can find the probability of being at below or above any certain score. Also, one of the other options here is if we click on the Between button up top, we can use the same calculator to find the probability of being between any two values. So let's say that we wanted to know the probability of having an IQ score that is between 85 and 115. We still have our mean of 100 and a standard deviation of 15. We put in our lower value here to show that x would be greater than or equal to 85 and less than or equal to 115. When we hit compute, we see that right at 68% of all of the values, 2/3 of everybody in the middle of our distribution will have IQs between 85 and 115. Now, if you were really thinking about it, that shouldn't be too much of a surprise that we came out with 68% there, because the values that we happen to pick, 85 and 115, are one standard deviation below and above the mean. So it makes perfect sense, according to the empirical rule, that we would end up with 68% there. But that's how you use the normal distribution calculator to compute probabilities of being at